Okay, so this is the 6th FRQ from the AP Chemistry exam in 2018. And part A says, voltage, find that, identify the missing component and explain its importance for attaining a non-zero voltage. As you can see here, we have a voltaic cell, so it's missing the salt bridge. And that's the reason why the cell has a voltage that is 0, right? The question tells you that it's a galvanic cell, so you just know that this one needs a salt bridge because the overall charge should still be balanced. Like the anion is continuously losing electrons, right? So eventually it's going to get to a point where it's lost so many electrons, it's so positive that it doesn't really want to lose electrons anymore. So then that's when you need the anions to flow through the salt bridge to the anode to make it more negative so that it can keep losing electrons. Okay, so that's basically the gist of the first part of this FRQ. Now for part B, which asks about the value of Ecell. So I don't know why it just keeps doing that, but basically what you do is you do the E of cathode minus anode, and then you can tell that the chromium here is the chromium is the anode in the cell, because silver is generally a cathode because it's really low on table J, so on the activity series. So yeah, you plug the numbers in and you get that, like the E cathode minus E anode equals the standard reduction potential, all that, and you get that the value of the, what's it called again? The standard reduction potential of chromium is negative 0.74. And then now for part 2, balance the ionic equation. So since we see that silver only loses 1 electron, we have to multiply the silver reaction by 3. And then since we know which one's the anode, which one's the cathode, we also know which way to put the half reaction so that they balance out. So for example, the solid chromium will be on the left side of the reaction, and that aqueous chromium will be on the right, because from left to right, the oxidation of chromium needs to increase from 0 to +3 because it's being oxidized as the anode, right? And now the same process, but the reverse for the silver, because since it's the cathode, it has to be reduced going from left to right. Alright. For the next part, it was asking about the delta G, I think. I don't know why I just did that again. It just keeps zooming to jumping forward, I guess. Something's cutting out. I think this screen recording was working weird.